Okay, so we're graphing linear inequalities. So we're going to talk about our different symbols. So this symbol, what symbol is it? The first one. Less than. Okay, does anybody remember what kind of line we would graph an inequality with? Dashed or solid? Dashed. Why? Because it's not equal. You're exactly right. So this would be a dashed line. Okay, and if it says y is less, then you would shade where? If something's less than you, is that above or below? Shade below the line. The reason I wrote y with the symbol is because I want you to realize that y has to be on the left when you read it for this to be true. Okay? Now, what symbol is this? Greater than? Okay, what kind of line would that be? Dashed, because it's not equal to. Okay, and I want you to realize y is greater. If something's greater than you, you would be what? Above. Now, one thing I want you to realize on both of these is, does a dashed line hold a solution? No, because it's not equal to, and on the line represents your equal to. Okay, so if you ever see a dashed line and I ask you, hey, is a point on that dashed line a solution, what would you say? No, so I want you to realize dashed lines do not hold solutions. Okay, what symbol is this? Less than or equal to. Okay, what kind of line would this be? Solid. Why? Because it's equal to. You're exactly right. Okay, and if it says y is less than or equal to, where are you shading? You're exactly right. Okay, and then last but not least, greater than or equal to. Solid line or dashed line? And shade above or below. Now, solid lines. Do solid lines hold solutions? Yes. Where else do you find solutions on an inequality graph? Where? In the shaded area. So I want you to realize solutions are on solid lines and in shaded areas. Okay, I do want you to relate. It says hint on shading. Put a pencil on the diagonal line and drag straight up for above and down for below. Because sometimes when the lines get super steep, it is hard to tell what's above and what's below. So I'm going to show you this trick with your pencil, okay, and it'll always work. Okay, unless it's a vertical line. Vertical lines, you just have to think, where is x smaller, where is x bigger. So if it's a vertical, undefined x equals, or x inequality equation, then you'll have to figure out left or right, okay? So let's look at the first one. These are in slope-intercept form, which means we like these because right away we have our slope, our intercept, and we can graph, right? So knowing that, this says y is less than 3x plus 1. Okay, so before we even get started, I'm going to write two things down. If y is less, where are we shading? So we're going to shade below. And then if y is less, what kind of line are we going to have? Okay, so those are the two things that I know. One reason I write these down is because sometimes y'all write in pen and you'll draw a solid line just out of habit, and then you're like, oh man, that was supposed to be a dashed line. If you have it written, labeled clearly, I will still give you credit if you wrote dashed line and you drew a solid line. Does that make sense? Okay, because if you're like me and I use pen for notes, I mess up all the time. It's okay. So I like using pencil when I key things because I will literally erase to make the dashes. It's fine. Okay. So it says the line is dashed, which we just wrote, because the inequality is not equal, therefore there's not all of the line there. Okay, so we're going to go ahead and plot points. So remember, your number by itself is your what? Y-intercept. So I'm going to go to my y-axis, and at positive 1, I'm going to put a point. What is the number in front of x? That's my slope. Now, I always want slope to be a fraction, so what can I put under it to not change anything? 1. Now, this is positive, so from left to right, it should go up, right? Okay, so that means I'm going to rise because it's positive 3 and run to the right because it's positive 1. So rise 1, 2, 3, run 1. And then I can also do opposite, opposite, and go down 1, 2, 3, left 1. Now, it is important to go all the way across your graph for these because if you notice, I ask you if these points are solutions, and what if one of them's on the line, but our line is crooked because we didn't plot all the way across, and we'll say no or yes when it should have been the opposite. Does that make sense? So it is important to graph these all the way. So it says, since this is an inequality, we need to shade, color. Okay, first off, let's make our line dash. I like to just draw a dash through the dots or connect every other dot, or however you do it. I'm happy as long as it's dashed. Now, we did say we were going to shade where? Below. Okay, that's all this was asking. Y is less than. Then we need to shade below. So put your pen on the line or pencil, and below is down, right? So I'm going to pull my pencil or my pen down. Do you see how it covered the right side of that graph? It's because that's where below the line is. Okay? Now, I have these 3 points down here, and there's 2 ways to know if they're solutions or not. We can plug them into the equation, which I'm going to show you. You don't have to do this every time, especially if you graph it, because if you graph it, shouldn't you know just looking at the graph? Yes. So we're going to do it both ways. So negative 1, negative 2. Negative 1, negative 2. Where is that? On the what? On what kind of line? So is it a solution? No. Because it's on the dashed line. Okay, now if I were to plug it into my equation, I'm going to rewrite my equation so we see it. Y is less than 3x plus 1. So if I plug it in, I want you to realize this is my x, this is my y. So I'm going to replace my letters with parentheses, and I'm going to plug them in. So x goes here with negative 1, y goes here with negative 2. Does that make sense, how I plugged it in? So knowing that, we are literally, y'all, don't even like make this harder than you have to. Where's my pink calculator? Type that right side in, because this is just negative 2, right? Negative 2 is less, so if we type this in, we get 3 parentheses negative 1 parentheses plus 1. and it gives me negative 2. Is negative 2 less than negative 2? No. So this is false. Therefore, it's not a solution. So we just proved it. Okay? So the next one says, is 3, 1 a solution? So if I go to 3, 1, where is that? In the shaded area. So should it be a solution? Yes. So then again, we're going to prove it. So this is good practice too, because in standard form, I like when y'all plug it in to check a point. And I'll show y'all why here in a second. So I have y is less than 3 plus 1. So x goes here, y goes here. So I get 1 is less. Y'all, what's 3 times 3 plus 1? Is 1 less than 10? Yes, so this is true. Therefore, it is a solution. Now, I want you to realize the shaded area is always true. Therefore, the other side should be what? False. Okay. So if you ever have to test a point to shade, you always shade the true side. So if you test a point and it's over here and it says false, then you know the other side has to be true. Does that make sense? Okay. So last one, negative 2, 2. Is that a solution? No. It's in a non-shaded area. So again, if we prove it, we get 2 is less than 3 times negative 2 plus 1, which is negative 6 plus 1 is negative 5. Is 2 less than negative 5? No, so that's false. Any questions with that? Okay. What do you think the easiest point to test is? Huh? I think I heard it a couple times. 0, 0. The origin, right? Because if you plug in 0, what does it do? Gives you 0. Like, really, there's no math involved because you know anything times 0 is 0. Okay, so we'll talk about that here in a second. Okay, this last one, it's graphed for us. It says, write the inequality of the graph to the right in slope-intercept form. So we're going to try to figure out the symbol first. Okay? What kind of line do I have? Dash. So is it going to be equal to? No. And is it shaded above or below? Above. So what symbol are we going to use? Greater. So I'm going to have y is greater. So I need to find, because it's slope-intercept form, I need to find my m and my b. My slope and my y-intercept. So what's the easiest one to find? 2, which is my what? My b. Now, is that a positive 2 or a negative 2? Positive. Okay, and then what's my slope? How can I find my slope? Rise over run. Now, first off, what kind of slope is it? Positive or negative? Negative. So I'm going to go ahead and put that negative so I don't forget. And I know that I'm rising 1, 2, and I'm running 1, 2, 3. So I have negative 2/3 x plus 2. And there's my answer. Easy enough, right? Yeah. Okay. So now let's look at standard form. Who remembers the easiest way to graph standard form? What do we call that? The cover-up method. So we're going to plug in 0 for the opposite to find our intercepts, and by just using the cover-up method. Okay, so knowing that, it says since the inequality is written in standard form, we will use the x and y intercepts to graph the line. The x-intercept, which is where y equals 0, so we cover up y. How would you solve for x? Divide both sides by what? 3. What's 6 divided by 3? 2. So I know that my x-intercept is 2, 0. So on my x-axis, I'm going to go put a point at 2. And then the y-intercept, which is where x equals 0, so I'm going to cover up x because anything times 0 is 0. That's why I'm able to do that. How would I solve this one? Divide by negative 2. What's 6 divided by negative 2? Negative 3. So I know that it's negative 3. Now, I want you to realize there are 2 ways to find slope. Could we just go to the 2 points we just plotted and do our rise over run? Yeah, which would give us rise 1, 2, 3, run 1, 2. So we know our slope is 3 over 2. Now, I want you to also realize we could have done opposite of A, which would have been negative 3 over B, which is negative 2, and 2 negatives make A positive. So did it match? Yes. So rise 3, run 2, rise 1, 2, 3, run 2. Okay, solid line or dashed line? Solid because it's equal to. Now, this one is not the same. You can't just look at your symbol and say, oh, above or below, because it's not in slope-intercept form. Y is not by itself. And I want you to realize, so here just talking about, it's going to be a solid line. Okay, I want you to realize y is negative, correct? So technically, if I were to solve for y, I would have to divide both sides by negative 2. And wouldn't that flip my symbol? Yeah, so would I shade above or below here? If I have to flip it, it's going to end up being below. So that's why I don't like y'all looking at the symbol when it's in standard form. I'm going to show you what I like to do. But it says since the coefficient of y is negative, if I can spell negative, ignore my first I. So we really need to shade less than or below the line. I prefer you check a point. Y'all, is 0, 0 on the line? No, so you can check it. You can never check a point on the line. Okay, don't check a point on the line because you're just going to have extra work. Okay, check a point that's not on the line. If 0, 0 is not on the line, y'all, plug it in because guess what? It always gives you 0. So if I'm testing the point 0, 0, I plugged it in. Well, what's 3 times 0? Minus 2 times 0 is 0, and 0 minus 0 is 0. Is 0 less than or equal or greater than or equal to 6? No, so this side is false. So if this side's false, what's this side? True. And where do we always shade? The true side. Does that make sense on testing a point? Okay. Yeah, if it's in standard form because x and y are on the same side. Now, if 0, 0 is on the line, can you test that point? No. So only if 0, 0 is not on the line is that a test point. Okay? If it's on the line, could you technically test any point? Yeah, you can I mean, if you wanted to test this point, or I always try to choose one that's on an axis, because then at least one of the numbers is 0, and it's quick and easier to solve. Does that make sense? So I'll do a different point on this one, just to show you that it can be any point. 0, 0 is just the simplest. So knowing that, we have this one. Okay, so since the inequality is written in standard form again, we will find the x and y intercepts. The x-intercept, which is when y equals 0, so I'm going to cover up y. What would I divide both sides by? What's in front of my x? 2. So when I divide negative 20 by 2, what do I get? Huh? Negative 10. So my x-intercept on my x-axis is negative 10. And then my y-intercept is when I cover up x, because x is 0. And what would I divide both sides by? -5. What's -20 divided by -5? 4. So 1, 2, 3, 4. How do y'all prefer to find slope? Do y'all prefer rise over run, or do you prefer to do opposite of A over B? Both? Doesn't matter? Which one you do? No. So first off, we should know that this is a positive slope, right? Okay, what's opposite of +2? -2 over B, which is -5. So I know my slope is rise 2, run 5. And if I do rise 2, run 1, 2, 3, 4, 5, and I do it again, did it bring me to my other intercept? Yes. I can't count. Okay, so the line is going to be solid or dashed? Dashed. So we're just going to draw dashes. Now I want you to realize the coefficient of y, is it positive or negative? Negative. So technically here we would have to flip our symbol if we solved, but I just want to test a point. Is 0, 0 on my line? No, but I told you I was going to show you a different point, so we could pick any point. So I'm going to pick this one, 5, 0. Okay, so I'm going to plug in to my equation. So 2 times x is 5 minus 5 times 0 is less than -20. Well, 2 times 5 is 10, minus 0 is just 10. Is 10, oh, not equal to, sorry. Is 10 less than -20? No, so this is a false point. So where am I going to shade? Above. Because if that side's false, this side has to be true. Okay, one more, then I'm done talking. Okay, I want you to realize this is the same graph as the one on the front, and on the one on the front told us to put it in slope-intercept form. What form does this one say? Standard form. So just a reminder, standard form is when x and y are on the same side. Okay, so let's write it in slope-intercept form because we know that, and that's easy to do. So I want you to realize we have y. Now, what's my symbol going to be? It's a dashed line and it's shaded above. If something's above you, it's greater or less? Greater. So I'm going to just have greater. It's not equal to because it's a dashed line. Okay, what's my slope? Rise 2, run 1, 2, 3, and it's negative. And my y-intercept is +2. Now, does standard form ever have fractions? Have y'all ever seen a fraction in standard form? No. So I know I have to get rid of my fraction. How do I get rid of a divide by 3 in my fraction? Multiply by 3, but I have to do it to the whole equation, or inequality, or it's not equal anymore. So when I put a 3 here, I'm going to distribute that 3. 3 times y is what? 3y. Bring down my symbol. Now 3 times this, doesn't it just cancel the denominator? And I still have -2x. And then 3 times +2 is +6. Everybody okay with that? Okay, now what else do I know is different from here and in standard form? Where does my x need to be? On the same side with my y, right? So how do I move a -2x? +2x. Now I know that the x actually has to be in front. And what kind of 3 is that? Positive or negative? So I end up getting 2x plus 3y is greater than 6. Any questions with that? So just remember, when you're trying to put something in standard form, start with what you know. Put it in slope-intercept form. Get rid of the fraction if there is one, and just get x and y on the same side. That's all you're doing. Get rid of fractions, x and y on the same side. Okay?